as with the first page, I do not have enough room on this to do my working out, so I've written them all on a piece of square paper. They are the same, promise. So starting off with the top left-hand equation, 4x add 8 equals negative 28 take away 5x. We need to remove the smallest amount of the unknown. Now, everyone's always going to say, oh, 4 is smaller than 5, but is 4x smaller than negative 5x? Remember, negatives are below 0, therefore they are smaller. So we're actually going to remove the negative 5x. By doing the inverse or the opposite of negative 5x is positive 5x. So 4x add 5x is 9x. The constant of 8 is unchanged. Negative 28 is a constant, so that is unchanged. And negative 5x add 5x, well, that just removes it. Now we have our usual two-sided equation, and we continue as normal. We have a constant on the same side as an unknown. We need to remove that by doing the inverse. So we've got 9x, and we've removed the positive 8. Negative 28, take away another 8. Remember, you're going further below 0, that's going to be negative 36. The fact that those numbers tally up nicely means we've probably got it correct. Remove the coefficient by dividing. That leaves us with 1x equals negative 4. Okay, next one. 34 take away 6x equals 6 take away 10x. So again, we've got two unknowns. We've got negative 6x and we've got negative 10x. Which is smaller? Put it this way, which would you least like to be outside in a swimming costume in? Definitely negative 10. I wouldn't like either, to be honest. So negative 10 is smaller. It is the lowest. We're going to do the inverse, which is adding 10x. 34 is a constant, so it's not affected by 10x. If I've got negative 6x and I add 10x, that takes me into positive x's. That is the reason we use the smallest amount of x's, the smallest amount of unknowns. It's because it gives us a positive amount of x, a positive unknown. We continue as we did before, first of all removing the constant. And then removing the coefficient. Each time we're doing the inverse operation on the opposite side of the equation. And the third one here is more of the same. Thinking about it, 2 is a smaller number, but negative 9 is a smaller value, a lesser value. All of these have ended up in the form we like, which is x equals something rather than something equals x. But you need to remember that they are exactly the same, really. 2x add 9x is 11x. Negative 55, remove the 9x. Got a constant there of 11. I don't know about you, but my questions this time have really liked the number 11. It's cropped up all over the place. Negative 55, take away another 11 gives me negative 66. And then finally I divide through by the coefficient, giving me x equals negative 6. Right, now the next two questions we can tell they're going to want fractions. It says use fractions pretty well. They've given us a fraction box, so we're going to need fractions. Oh, I forgot an x there. 8, 3x, not just 8. Okay. Really be careful. I've had so many instances where students of mine have answered a question that they've made up out the top of their head because they've mixed up questions 7 and 8. So don't be daft. Don't do that. Don't do what I just did. Exactly the same method here. The only thing that's going to be different is the final step. Find the smallest amount of the unknown. The smallest amount of the unknown is 3x. I've got that song going around in my head now from Frozen 2, Into the Unknown. I'm not going to sing it, don't worry. Negative 8 left on that side. Negative 16 is unaffected by that. 9x take away 3x is positive 6x. Now we make sure that we haven't got any constants mixing with any unknowns. Right, this is where it becomes slightly different. We need to divide by 6, but 8 divided by 6 is not an integer. However, we can simplify that fraction because both the numerator and the denominator are multiples of 2. Okay, so 4/3 would be my x here. Some people would be tempted to put 1.3 recurring if they had that in an exam, but where possible use fractions. They're much more accurate. I know you don't like them as much, but tough. Another question here, same kind of thing, smallest amount of the unknown. Which is 20x this time. Quite large, small amounts. Which leaves me with 6 add 15x equals 15. Let's get those constants sorted out. 15x equals 9. And let's divide by the coefficient. Gives me x equals 9 over 15. Again, we can simplify that fraction, so they're both multiples of 3, which means that we can simplify it to 3/5. Okay, I am thinking of a number, because doesn't everyone do that in their free time? I multiply by 6 and add 160. I get the same answer if I multiply by 12 and subtract 8. What is my number? You need to form and solve this equation. So let's call our number x, because let's face it, that's what we usually call numbers. Multiply it by 6, that gives me 6x. Add 160. I get the same answer, so it is equal if I multiply by 12 and subtract 8. We have a two-sided equation. Let's just do exactly what we've been doing before. We start off by removing the smallest amount of the unknown. We then make sure that we don't have a constant mixed with an unknown. And finally, we divide by the coefficient. Oh my goodness, 2 and 4, 28. And what's my number? My number is 28. Okay, your number will be different, because of course you thought of it. Hopefully that's helpful.